Hello students, welcome again to my Applied Science College channel. Today we are going to also proceed with chemistry, and specifically we are going to look on the mole concept, and we shall just be able to go straight to the sampled questions. And I have some 3 questions here that we are supposed to discuss, to ask you, and after some time then we shall be able to see how the same questions are supposed to be answered. I'll be moving with you slowly by slowly, as long as you'll be able to understand what I'm emphasizing in as far as those small concepts are concerned. And within me here, I have some 3 questions here. We have the first question, second question, and the third questions. All of them, I'm just going to ask them today, and immediately I finish asking you, I'll be able to now to discuss the same questions. You'll be able to try them on your own, and after you have tried, that's when you will be able to also to listen to to go through my discussion, and then you see how those questions are supposed to be answered. But I just want to thank everyone who is viewing my channel and who is liking and also is also sharing my channel. Otherwise, just welcome very much. We have had a very long holiday, but we have come back to class because education is the key to life. So, without wasting time here, let me just go through those questions, and then we see how they are supposed to be answered. And question 1, it reads, what is the molarity of a solution formed by dissolving 5.0 grams of sodium hydroxide in enough water to make 250 cubic centimeter solution, or 250 mils of solution? Question 2. Okay, let me repeat question 1 for those ones who have not heard what I've requested. What is the molarity of a solution formed by dissolving 5 grams of sodium hydroxide in enough water to make 250 mils of a solution? Question 2. How many grams of potassium chloride are needed to prepare 1.5 liter of 0.2 molar solution? Question 3. Let me also repeat question 2. How many grams of potassium chloride, written as KCl, are needed to prepare 1.5 liters of 0.200 molar solution? Question 3. And I read, concentrated sulfuric acid is 95%. Let me repeat. Concentrated sulfuric acid is 95% sulfuric acid by mass and has a density of 1.834 grams per mole. What is the molarity of this solution? A concentrated sulfuric acid is 95% by mass and has a density of 1.834 grams per mole. What is the molarity of this solution? So, I just want to start by discussing the first question, whereby it was asking. This is how these questions are supposed to be answered, especially for the new Form 3s. For the Form 3s, because the Form 4s have been exposed to the mole concept. But for the Form 3s, they can have so many challenges because they are new in this new topic of mole concept. So the question 1 was reading like this. What is the molarity of a solution formed by dissolving 5 grams of sodium hydroxide in enough water to make to 250 mils of solution? So this is how this question is supposed to be answered. This is now the solution. You need to get the mass that you have been given in the question is the mass of the solute, which is sodium hydroxide. It is 50 grams. And the volume of the solution is 250 mils. So the constant needed are the molar mass of sodium hydroxide are the relative the relative atomic masses. Of sodium it's 23 grams per mole, oxygen is 16 grams per mole, and then we also have hydrogen, which is 1 gram per mole. So now the real solution, this is how it's supposed to be approached. First of all, you are supposed to calculate the mass of sodium hydroxide, whereby molar mass is equals to 23, that is the relative atomic mass of sodium, plus 16, which is oxygen, relative atomic mass of oxygen, and then 1, which is the relative atomic mass of hydrogen, which is totaling to 40 grams. After you have calculated the mass of sodium hydroxide, then the second step that you are supposed to undergo, you need to convert this mass of sodium hydroxide into moles. So we went to an extent of converting the mass of sodium hydroxide to moles. Moles, it's always given with this formula. Moles is equals to mass over molar mass. So in this case, we equated we equated the formula and said 55 grams over 40. Remember, 40 is the molar mass of sodium hydroxide, which was giving us 0.125 moles. After you have found the number of moles, then you are supposed also to convert the volume of the solution from the milliliters to liters, whereby the volume is equals to, remember we were requested from the above question, it's supposed to be into 250, then milliliters, then we multiply by 1 liter and then we divide by 1000, because 1000 milliliters makes up 1 liter. So we are going to take 1 liter and then we divide by 1000 milliliters, which was giving us 0.250 liters. Then after we have done that, we were supposed also to calculate the molarity of that. So you can, molarity, it's always given as is equals to the moles of the solute over the liters of solution, which we did a good substitution and got which was equals to 0.125 moles over 0.250 liters. So we were getting 0.5 molar, or in a simplest way of doing it, you are just supposed to ask yourself, you have the 5 grams of the sodium hydroxide and they were dissolved in 250 cubic centimeters of that solution. Then you are supposed to ask yourself, what about in 1000? Then you cross multiply there. You will be able to find that in 1000 you only need 20 grams. So in the long run, after you have found the 20 grams, you are supposed now to ask yourself, if 1 molar you are supposed to dissolve 40 grams, then what about for 20 grams? Then you cross multiply that one, then you will also end up with the same answer of 0.5 molar as it has been written there. So we are through with the question 1. Then we are going to also to see how this question 2 is supposed to be answered. Question 2, we were asked how many grams of potassium chloride, KCl, are needed to prepare 1.5 liter of 0.200 molar solution. This is how it's supposed to be solved. You are supposed, given that the volume of solution is 1.5, it has been requested in the it has been indicated in the question, then the molarity is equals to 0.200 molar, or you can as well as write 0.200 mole per liter. So the constants needed: potassium, it has a relative atomic mass of 39.1 grams per mole. Chlorine, it has 35.5 grams per mole. So the solution is supposed to do this. First of all, you are supposed to calculate the molar mass of potassium chlorate. So the molar mass of potassium chlorate is equals to that 39.1, that is potassium, plus 35.45, that is chlorine, which is equals to 74.55 grams per mole. So secondly, you are supposed to also to calculate the number of moles of potassium chloride required. So moles is equals to molarity times volume. Molarity times volume, which is 0.2, and then we multiply it by 1.5 liters, which is giving us 0.3 moles. Let N be 3. So the number 0.3 moles, let those the number of moles be is equals to 0.3 moles. Finally, convert the moles using the formula. Mass is equals to N multiplied by the molecular mass. So you are going to get 0.3 moles times 74.55 grams, which is the molecular mass, then which is giving you 22.365 grams. So, or you can just simply just do the other way around. You are supposed just to ask yourself, one molar is equivalent of that potassium chlorate. You are supposed to weigh how many grams? 74.55 grams. What about for 0.2? This is supposed to be 0.2. Let me just put it. Let me put it clearly so that you can be able to see. This is supposed to be 0.2 m, right? So you are supposed to do just simple like this. You cross multiply 0.2 times 74.55 over 1, which was giving us 41 grams. And then for 14 grams, it was giving us 14 grams, 0.91 grams. 14.91 grams. I beg your pardon. 14.1 gram, you are supposed to ask yourself, 14.91 gram is for 1 liter. What about for 1.5? Then you just cross multiply it, and then you get it to 22.265, which is the same as 22.365, like this. So we have so many ways of calculating this question. You can do it like this, then you can either do it like this, but this one is the simplest way because you don't go into so many steps. Because we have just equated a few figures, but we have still arrived to the same answer as per the one that is on top there. Okay, let us go to question 3. Question 3, it was asking, concentrated sulfuric acid is 95% sulfuric acid by mass and has a density of 1.834 grams per mole. What is the molarity of this solution? So this is solving. The molar mass of sulfuric acid is calculated by summing the atomic masses of its constant atoms. So you just write sulfuric acid, then you get the relative atomic mass of that sulfuric acid, which is hydrogen has got 1.001, because in that equation we have 2 atoms of hydrogen. We are getting 2 times, we were getting 2.016 grams per mole. So sulfur, it is 32.06. That is the relative atomic mass of sulfur, and then grams per mole. But in this case, in that compound of sulfuric acid, it is only 1 atom of sulfur. That's why we are multiplying it by 1. So it was giving us 32.06 grams per mole. Then oxygen, because oxygen, they are 4 atoms of oxygen, and the relative atomic mass of oxygen, it is 16.00 grams per mole. Then we multiply it by 4, since there are only 4 atoms of oxygen in that compound. So it was giving us 64.00 grams per mole. Then you take the total mass, you add 21.016 plus 32.06, and then you finally add 64.00. All these are grams per mole. Then you will end up with 98.06 grams per mole. Then step 2, you are also supposed to calculate the mass of sulfuric acid specific. Sulfuric acid, I beg your pardon. You are supposed to calculate the mass of sulfuric acid in the sulfuric acid in specific volume of solution. For example, in 1 liter or just 1,000 cubic centimeters. So the mass of 1 liter of solution is, mass of a solution is equals to the volume times density. So you take that, the density of the sulfuric acid, and then you multiply it by 1,000 cubic centimeters. 1,000 cubic centimeters or 1,000 milliliters, which is 1,000 times 1.834 grams per mole. It was giving us 1,830 grams. Since the solution is 95% sulfuric acid by mass, the mass of pure acid, sulfuric acid in a liter of solution is going to be mass of pure acid is equals to 0.95 times 1834, which is this one here. Let me just show you, which is this one here, and then you multiply it by 95%, or 95 over 100, or you can as well as just write 95 over 100 is the same as 0.95, and then you multiply by 1834 grams. So it was giving finally answer as 174. It was giving the final answer as 17 point, okay, it was giving the final answer as 1,742.3 grams. So last but not least, you are supposed also now to calculate the number of moles of sulfuric acid, that mass using its molar mass. Moles is equal to mass over molar mass, which is this one, and then you divide by the molecular mass of sulfuric acid, which we found it earlier here. As you can see, this one, it is being now transferred here, and then you get 17.76 moles in 1,000, that is. So you can, after you have found 17.76 moles, then you get the molarity is equals to moles of a solute over moles of a solution. It is always that way. Then is equal to 17.76 moles over 1 liter, which is giving us what? 17.76 molar. So I hope we have come to the end of our virtual practical class. These are sampled questions too. Sampled question 2, but it has 3 questions. So we shall be proceeding with the more questions as time goes by. And for those ones who have not subscribed to the channel, please just do so, and also make sure you like and share and also comment on this video. Otherwise, thank you and welcome again in the next virtual practical class, and we shall be able to work more effectively. Bye bye.